Unit 2 of Data Management. I want to let you know that I hope you are doing well in the course so far and you've written your first unit test. Please make sure as we take that up, if you need some help still, please come and see me for any extra help. So the biggest shift between Unit 1, which was one variable statistics, to Unit 2, which deals with two variable statistics, is in Unit 1, ladies and gentlemen, whenever we plotted something, we had frequency versus some value, okay? So we always have frequency on the y-axis. That's going to change. That's one variable statistics. So now in two variable statistics, we're going to compare something to something else, similar to what you're going to be doing in your culminating project, okay? How does time spent texting affect your marks, for example? Those are two different variables to compare relationship. Okay, so today we're going to take a look at what the correlation is, and we're going to be developing that through scatter plots. Okay, before we get to scatter plots, we do have to talk about relationships and what they look like and how you can see them. Okay, so now we're in two variable stats, ladies and gentlemen, so don't forget that. Okay, and we're investigating a relationship between two random variables. Okay, so you can see this in many ways. So first of all, I could give you a graph, and from a graph, ladies and gentlemen, you're going to have independent variable is the x, and your dependent variable is your y-axis. Okay, again, Unit 1, instead of having a dependent variable here, we just have frequency. So that changes things. Okay, you can also see it in a table of values. So someone could list some values that you could lead to graphing, or just take a look. Don't forget, ladies and gentlemen, you could also have a table that goes horizontal as opposed to vertical. X is always going to be the first one you see, regardless of which way the table is oriented. You can have it in words, ladies and gentlemen. So in words, you could say y versus x, y against x, or dependent against independent. Another way we're doing this for our project is, does blank affect blank? Okay, I'm looking outside right now, it's snowing. So how does temperature decrease? How does the effect of temperature change the number of hot chocolate sales, right? So those are two things that are related. Another type of relationship that you could have, folks, is you could be given also an equation, okay? All right, so ladies and gentlemen, if you quickly take a look in your textbook on page 158, or just bear with me, ladies and gentlemen, here are two examples of scatter plots, okay? So it just says to, for each of the following sets in the give you tables of values, create a scatter plot and describe any patterns you see. So first thing I want you to know is that I plotted the dots, and then I did what's called the line of best fit, okay? Because this is close to a linear relationship, I chose a straight line, okay? You could have curves of best fit, for example, to fit a parabola or an exponential function as well. And you're going to learn how to do that throughout this unit, okay? So taking a look at example A, I plotted all my points. So I got 1, 2, 3, 4, 5, 6, 7 points that I plotted, and then I drew a line of best fit. Now, the first thing we need to know is what happens. So as x increases, what's happening? Well, you're going to see that y is decreasing. So let's write that in as a description. So as x increases, y decreases. And you may remember this from grade 9 or 10. What do we call that? We call that, well, obviously that's called a negative trend, okay? Or some people could remember a negative slope, that's fine. Okay, so we're going to call this a negative trend. And for data management, we're going to take it further and we're going to say negative correlation. In grade 10, you may have heard of that word, but we're going to learn all about how correlation works, how we find it, and we use technology to help calculate an actual value of it. Okay? So negative correlation means you've got a downward trend. That's another word. You could have a negative trend. Okay? Taking a look, and notice, folks, that when we take a look at strength, notice that with that line of best fit, most of the data is very close together. So I would have said that's a strong or a very strong negative correlation. Okay? So look at example B. Again, I plotted all the points that are on the table values. And remember when you draw a line of best fit, folks, that you have to get the trend of the data. So please understand that the trend is going in a diagonal this way, okay? And you want to try to maximize the number of points you go through and make sure you got equal points above or below. So I've seen people in the past, I'm just going to rinse this, I've seen people in the past, like, let me just undo that for a second. Okay, so I've seen people in the past, ladies and gentlemen, that have gone like this. And said, aha, Ms. R, I've got equal on equal sides. Okay? The problem is, folks, you're missing the trend of the data. So you find the trend first before you draw that line. Okay? I usually take a pencil and try to cover as many points with my pencil to give you the trend, and then I use a ruler, hopefully a clear ruler, to make sure we can balance that out. So what we know is we're describing graph B here, folks. And what's happening as we increase x? So as x increases, what's happening to y? Y is also increasing, right? Okay. So again, instead of a negative trend, we can call this a what? Positive trend, or you could have called this an upward trend from before. It's fine. Okay, so this is a positive trend. Okay, and we call that in data management. We're going to take that a step further and call it a positive correlation. All right. Okay. And looking at, if I was to describe the strength of the study journal, it's not as strong as example A. Example B might be a medium type strength. Okay, so you could say a medium positive correlation for this one. You might say, hey, Ms. R, how do we know what the strength is? Well, I will tell you that if you go to your textbook, and I just copied and pasted this out, folks, and you want to make sure you document this, okay? See page 163, okay? And this is where we're talking about the correlation coefficient. We're actually going to calculate this, hopefully using technology. I would suggest doing the pen and paper method. Does not work very well for this, okay? And what I want you to do is take a look at the diagram here, okay? We have what's called a positive correlation and a negative correlation, and if it's negative, if it's negative, you'll see it when you do your calculation with a negative sign in front, okay? In your textbook, according to the people who wrote that textbook, they qualify the range for weak, middle to moderate to thirds. So think about it. Weak is the first third, moderate is the second third, and strong is the last third. If you get an R value that equals 0.98, I'm going to call that very strong. It's so close to 1, which is perfect. And if it's 1 or negative 1, we call those perfect correlations. What does that mean? It's all the data points fit in a straight line, and that's one of your linear examples you might remember from grade 10, where Johnny works $15 per hour, and you do the number of hours and how much money did he make. Okay, it was all in a straight line. Okay, so ladies and gentlemen, perfect is a good description, very good if you get close. I want to stress though, folks, if you think this textbook uses this in terms of rating the strength of your correlations. I have seen other textbooks use different ones, and the real world uses different ones. So if you Google negative or positive correlation or strong or weak correlation, you may see different models, okay? So I want to put down that the ranges, and please put this down too, that the ranges may change in the real world. You may work for a couple of companies, and one company may use this scale, another company might use a different scale. So please be aware of that. For the purposes of our course, we'll go with the textbook and we'll use these as our ratings. However, again, scales could change if you go to work in the field later on. Okay? All right. So, ladies and gentlemen, let's take a look at on page 160. There are some examples here. And ladies and gentlemen, I just copied and pasted them, so you don't need to write anything out. All it asks you to do is to classify the relationship between x and y. Okay? So let's take a look, positive versus negative, and let's try to take a look at putting a strength to it. All right. So with A, hopefully you notice it's like an upward trend or a positive trend, so that's going to be a positive correlation. And what do you think the strength is? Okay, those data points are pretty tight together, so I'm going to call this a strong positive correlation. And because we're writing correlation a lot today, I'm just going to go COR for correlation. Okay? Okay, let's look at example B. So example B, first of all, is our trend upward or downward. Hopefully you notice it's downward, so that means it's going to be negative. Okay? And let's take a look at those dots. Do they look like they all fit in a straight line? Absolutely. So I would call this a perfect negative correlation. Okay? All right, taking a look at C, ladies and gentlemen, if you cannot tell if it's an upward or a downward trend, then I would classify this as no correlation. Okay? If you tried using a graphing calculator, which you're going to do, and following the correlation on this, it'll probably give you a value like 0.02 or negative 0.03, which is very, very weak, which I would classify as a no correlation. So if you cannot tell a trend, meaning if it's going positive or negative, then I would classify it as a no correlation. All right, let's take a look at D and E. They actually look pretty similar, so I'm going to group them together. Hopefully everybody can see that there is an upward trend here on both of them. Okay. All right. So that tells us that we've got a positive correlation. And the data points aren't as close together as they should be. So I'm going to classify, you can do both of these together, folks. Both of these are going to be what's called moderate positive correlation. Okay. All right, last one is classifying F. Okay, hopefully you can tell the trend is going downward or negative. Okay, and the data points fairly close together. Yeah, I would say they are. So that's going to be a strong negative correlation. Please, folks, if you have any questions about these, come and see me in class on how to classify these. All right. So how can we tell exactly? Well, exactly is what this data method is about. We can get down to 3 or 4 decimal places in terms of finding this R value. Okay? So to find the correlation coefficient, which is letter R, we're going to learn how to do it using technology. Please understand, technology in this class is the way to go. It is much easier than having to do it long form. When you do it long form by hand, it gives you lots of sources of error, and it takes a long time. So to figure this out, folks, you have to remember that to get the correlation coefficient, you have to take the standard deviations of both x and y. Okay, so that's s at x and s at y, which are right here. Okay, and combine them to the combined standard deviation. So what a correlation coefficient does, folks, in a nutshell, is it'll take each data point and it'll say, hey, how far, so for example, how far am I away the y and how far away am I the x? Each one of them, they take a look at how far you are from the line of S. Okay? So that's basically what the correlation coefficient does, and then it puts all those together. Okay? So these are just taken, these formulas, folks, are just directly from your formula sheet. Okay? And I wouldn't worry too much about them, just on your check, be able to recognize, hey, if you forget what the letters stand for, you know that the correlation coefficient is R, covariance is so covariance is the numerator of your correlation coefficient. But ladies and gentlemen, please make sure we're going to use technology or learn how to do that. Okay? And you can try when you come in class to do the R value. I will show you. But next day we're going to learn the actual steps. Okay? So here's your homework, ladies and gentlemen, page 168, numbers 1, 2, 3, and 6. Just for those people who may not be believers in technology, I will show you on this page. You don't need to print it off or even look at it if you want to take a look. So here is from page 151A, first example that I graphed. Here are your x values, here are your y values. So the next column is you take each data point in the x and subtract it from the mean of the x value. Okay? Then you do the same for the y. Okay? So you're developing patterning. Okay? Then this is taking these two and multiplying them together. And then you go to square it to eliminate the negative. Okay? For the x and square it to eliminate for the y. Then you total them up. After you're done totaling them, then you throw them into the formula and you get an answer. So ladies and gentlemen, it is quite complicated. And think about your grandparents if they took this course, they had to do this all by hand. Okay, because they would have had technology back to do that. All right, so ignore this, folks. Understand we're going to use technology to help us. Okay, and just to recognize that although the formulas are complicated, the graphic calculator does the work for you. All right, have a great day, folks, and see me if you need any help identifying correlation types and scatter plots.